So we're starting topic 5A, and this is about polynomials. And this chapter is broken up into two parts, 5A and 5B. So we're going to learn a little bit about polynomials, doing solving, graphing. Again, everything with polynomials kind of follows quadratics. It's just that instead of being a squared term, x squared, it's x cubed or x to the fourth. But a lot of the things that we learn about quadratics, we kind of use for polynomials. That's why it's good to know your quadratics well. So let's first go through this little chart here. It says here the standard form of a polynomial function. So the standard form of a polynomial function arranges the terms by degree in descending numerical order. So polynomial functions, often we say p of x because it's like a polynomial. And basically, even though this looks terrible, basically it's the main thing is that this n, right, maybe that's a 5, and then this exponent would be a 4, and so on until you get to a0, which is just a constant. Better to probably look at an example. And by the way, that exponent has to be non-negative, so you can't have negative exponents. And also all of the coefficients are going to be real numbers, nothing with imaginary numbers. And basically, like this is an example of a polynomial that the first term is a cubic term because the exponent's a 3, then there's a quadratic term, there's a 2, the linear term, that's just the x to the first, and then your constant term. Let's go through some of the kind of words that we can use. So if you just have a function like, y equals 5, that's just a constant function. The number of terms here is 1 because there's just one term. And then in terms of when you have one term, we call it a monomial. Monomial. It's a fun word to say. So anytime you have, like for instance, there's a skip down here a couple rows, this 4x squared, that's just one term as well. That's a monomial too. Okay. And then in terms of degree, though, if this one, the highest degree is a 1x to the first, so this is linear. And then when it's an x squared term, that's quadratic. 3 terms is cubic. 4 terms, just like how many quarters are in a dollar, or how many sections are there in a football game, it's quarters. So quartic, gallons, quarts in a gallon, 4 quarts in a gallon. So quartic, that prefix quart is related to 4. All right, so now let's go to number of terms. So this second row here, x plus 4, there are 2 terms. We call that a binomial. And this has nothing to do with the degree of the terms. I just kind of screwed up how to spell that, binomial. This cubic function happens to have 3 terms. So because it has 3 terms, it's a trinomial. This one has 2 terms again, so it's a binomial. Last one, this one is quintic if it's degree 5. It has 4 terms, and usually in math, once you get to 4 terms, you just say polynomial of 4 terms. Like we just start calling them all polynomials when they have more than the 3 terms. Polynomial of 4 terms. You could probably go on Google and find there are probably more special names for things that have more terms than that, but we just don't get into it and learn them. All right, classifying polynomials. So this is, again, based on that little table that we just did. Write each polynomial in standard form. What is its classification of each polynomial by degree and by the number of terms? So the first thing you have to do is list it out the way you're supposed to list it, which is the highest degree first. That's from that key concept up above. So we do need to change this and say x squared plus 3x plus 5 because they were out of order. The highest degree, which is the highest exponent, has to go first. And in terms of the degree, the highest degree or highest exponent is a 2. So this is a quadratic. That's quadratic, that is classifying it by degree. Okay, and then in terms of classifying it by the number of terms, well, there are 3 terms, so it's a trinomial. The second one here, wow, lots of terms. Now I'm going to have to organize things. So my highest degree is x to the 4th. It looks like there's 2 x squared terms, so I'm just going to combine like terms. That's going to be plus 4x squared. And then I've got an x term plus 4x minus 12. So again, in terms of degree, the highest degree is degree 4. So it's a quartic. That's classifying it by degree. And then in terms of number of terms, there are 4 terms. So this is a polynomial of 4 terms. Fantastic. All right, moving along here. Now, some other classifications for polynomials. There's a few very important things here that are going to keep coming up. And this stuff is a big topic in pre-calc and then calculus. Calculus, we're always talking about when things are increasing or decreasing, when there's a change from decreasing to increasing, when that happens. That's a big topic in calculus. So this is an important thing to go through because it kind of helps frame things. So once you get to calculus, it's not like the first time you've started talking about this stuff, okay? So this first one, in terms of end behavior, it's what's happening at the ends. And so you kind of look at like this end and this end, and in both cases, it's going up and up. So we're going to say, in this book, we just say up and up. There are other ways to say this that are more technical, but this is all we're going to say at this time. And actually, we could just go through the next one too. The next one, since they're both going down, it's down and down. Down, and that's my and sign, down. Next one starts down, so you go from left to right, so down and up. Down and up. And this last one is coming in from the top, so it's up, going up on the left side, and down. And those are the only combinations you could possibly have. Now, in terms of turning points, how many turning points are there and what are they? Okay, so this one has, unfortunately, not enough room in this little box, so write small when we do this. There are 3 different turning points. It turns right here, and right here. And I am going to do this with you in the calculator. We'll talk about some of these other ones first, and I'm going to go back to that one. This one, the turning point, is right here. And that point, so there's one turning point, and that turning point is 1, 1. This one has no turning points. It never turns around. There is this thing, we call that a point of inflection, but there is no turning point. So this is just going to be none. And then this one, there's a turning point here, which I can't quite tell what that is, or here. All right. So how we find these turning points? Well, first of all, when you take calculus, that's how you find mins and maxes, where there's a study of finding mins and maxes because we learn how to take derivatives. And derivatives help us find out when the slope is 0, and then we can figure out when there's a turn, the slope is 0. And that's one of the big topics of calculus. However, we're not in calculus, we're in algebra 3. And therefore, we are going to instead type this into this formula, which is at the top there, 4, and now I'm back on this one on the left side. I'm not going to touch it, otherwise I'm going to lose my calculator. X to the 4th plus 6x cubed. Whoopsie toopsies. Let's start that over. 4x to the 4th plus 6x cubed minus x. All right, so that's what it looks like. And what I'm going to do is graph it, which I know we already know what it looks like graphed, and I'm probably going to change my window so I'm a little bit closer to things. So maybe I don't need -10, maybe -5 to 5. And maybe we only need to go, it's pretty small. Let's just go -5 to 5 here and see if we can see everything. That way we're zoomed in a little bit nicer. That's a little better, right? So to find that first, the leftmost turning point, I'm going to say second calc. It's a minimum because it was a low point. And then it's asking for the left bound and right bound thing. So get over here, left bound, hit enter, right bound, get to the right of that low point, hit enter. Guess you can get closer if you want to, enter. And it will tell you that it's negative 1.07 and then also that negative 1.03. So I'm going to write that on here. Small, negative 1.07, comma, negative 1.04 I wrote. I don't know. And then we can do the next one. So the next one's going to be, again, second calc. The next one is a maximum. I don't know why that is on like that. Second calc, we're going to find a maximum for, and again, we want this maximum here, left bound. That's a good left bound, right bound, get to the right of it. Hit enter. And then guess, you can guess something around there, it's fine. And it will tell you that the maximum is 0.27 and 0.17. So I wrote that one on here as well. I'll change the color a little bit. Negative 0.27, comma, 0.17. Like that. All right, the last one, I think you get the idea, is 0.22 and negative 1.15. This one over here, I'll just tell you what these are. Again, it's the same process, so it does take a little bit of time. Maybe possibly you could argue a little tedious. Negative 0.82 and negative 1.09. And then the other one is, this is kind of fun, 0.82. It's all symmetrical. And 1.09, like that. Very well. Now, in terms of increasing and decreasing, basically, like if you look at this one, it is decreasing until you get to there, and then it's increasing, and then it's decreasing, and then it's increasing. So what we say for something like this, and this is the worst one because it has so many terms, right? But you call out the decreasing things, and then you can call out the increasing things, or you can go back and forth. It just kind of depends on what you're doing. So for increasing, or let's do decreasing. Decreasing, it's decreasing. And it's such a long word to write all the time. We do this in calculus a lot. Is decreasing when x is, and you always do it in terms of x, when x is less than negative 1.07, and I know that number because it's right here. Okay, that when x is less than negative 1.7, to the left of negative 1.7, it is decreasing. It's also decreasing from like here to here. And those values are, so we're going to say negative 0.27 is less than x is less than, and then the other number, this x value here is 0.22. So that is when it's decreasing. It is increasing, I'll have to write it over here. and it's increasing from this point to this point, so that in terms of the x values, that's negative 1.07 is less than x is less than, and then that next point is negative 0.27. And it's also increasing from here and then forever else up that way. So that goes from x is greater than 0.22. Again, starting with the one like that is probably the worst thing to do because that is so many things. Let's do this next one. This is much easier. It's increasing and then it's decreasing. So just 2. So it's increasing, and maybe you can abbreviate with me if you want to, but like when you take the AP Calc test, you cannot like be writing your own little abbreviations for things. You tell those graders exactly what you mean when you do all those true response questions, which there's a lot of them. So it's increasing from when x is basically less than 1, and it's decreasing when x is greater than 1. So that one's not too bad. This one, it's increasing for all x. And the last one, now this one would have a few more, and we have the points, so it's not too terrible. It's decreasing twice. So decreasing, it doesn't really matter which one you write first. Decreasing, and when x is less than, it goes all the way to there. So all of this, when x is less than negative 0.82, as well as when x is greater than 0.82. And then it's increasing. Ooh, I touched the video. It's increasing from negative 0.82 less than x less than 0.82. That's pretty sloppy. I'm not using my preferred stylus right now either because the other one stopped working, and that's super annoying to me. All right, that was the worst of it, guys. Worst of the lesson there was just getting through all that. All right, this little box says something important. It says end behavior in order to know what it is. So when you are asked to look at an equation and state what the end behavior is, you don't even have to graph it. Basically, what you need to know is it an even function or an odd function? And then is the A positive or negative? Because when you look at what these look like up here, okay, and I'm going to just erase some of my marker markings because it's pretty sloppy there now with all that stuff that I wrote on there. Okay. If it's an even function, meaning the highest degree is even. So like the first two here, the left and the right one, they are even functions because the highest degree is an even exponent. And if it's a positive A, okay, it's up and up. Okay, so if you anytime think about if you had a parabola, y equals 2x squared, plus 6x plus 5, that is a parabola. It's right side up because you don't have a negative in front of the a value, so that is up and up. Okay, and if I did have a negative, then it would be down and down. And other degrees, as long as they're even degrees, are the same way. So what this is saying is, for even functions, okay, oops, no pen. For even functions, it's up and up if A is positive, and if it's negative, it's down and down. It's that simple. Now, if it's an odd function, looking at those, okay, it's either down and up or it's up and down. So this one, so you notice this function here is cubic, okay, and this one is also cubic. Lines are also odd functions. So if you just think of a simple y equals 2x plus 5, that has a positive slope, a positive a, that's going to be going like this, down and up, just like this one with a positive a, down and up. And then if it's going this direction, because it has a negative slope, or a negative a value, however you want to think of that leading coefficient, then it's up and then down. And that is what this says right here. All right, problem 3, graphing cubic functions. So it says, what is the graph of each cubic function? Describe the graph, including end behavior, turning points, and increasing and decreasing intervals. So when we're supposed to graph this, we don't have to get super careful about the points. It's really about us knowing some basic things about it. Now this one here, y equals x cubed, I know it's a cubic function, and it's going to be going, a is positive, so it should be doing something like this. Cubic functions sometimes do things like this, or they might have that kind of inflection point and they don't do anything at all. So we can go ahead and graph it on our calculator. 1/2 x cubed. Graph it. It looks like that. So it's got like an inflection point. And again, you don't have to get all perfect here with your points. It was just kind of the main thing here. So the end behavior is down and up, which you should have been able to answer that even before you graphed it, because you should just know that from that little table above. Turning points, there's none. Increasing or decreasing, well, it's increasing for all x, because it's always going up. And maybe I didn't say it earlier, but increasing, decreasing is always like reading. As you read from left to right, like what is it doing? All right, next one. Now again, we should be able to know end behavior on this one before we actually graph it, because my leading term here, let me just go back to this here. My leading term is actually, it's better to write this with negative x cubed plus 3x. The leading term is negative, and it's an odd function, so it should be something like this, because it's like a line with a negative slope, and it will be up and then down. So I think I'm going to just be able to say this right now. Up and down. I will graph it though, just to see. And I'll graph it the way they wrote it rather than the way I changed it, just in case I was wrong or something like that. It's always better to start with the original when you're doing something like that. All right, so that looks pretty good. And then in terms of the turning points, well, it could be a good point, but let's go second calc. We're going to find a minimum. Enter. Enter. Guess I'll get a little closer. Okay, so that's really 1, -2. I don't know why sometimes it doesn't nail it exactly right, but it's going to be 1, -2. The other one, second calc, and again, if you think you can do this on your own, you should. This is a maximum because it's a high point. Left bound may be here. Right bound may be here. So 1, 2. And maybe you want to graph that too. 1, 2. Take a look at it one more time. And basically it's going to be coming in from the top. turning, and then heading out like that. So it is then decreasing. We'll start with that just because that's the first thing. Decreasing, and it's decreasing until you get to 1. So when x is, sorry, that was negative 1, negative 1, negative 2. I just missed my little negative there. So it's decreasing when x is less than negative 1, and it's decreasing from here on, and that's when x is greater than 1. And then it's increasing from negative 1 is less than x is less than 1, between negative 1 and 1. Again, you're always doing increasing and decreasing as how it relates to x, not how it relates to y, which is a little goofy because you'd think if you're talking about going up and down, you'd be talking about like a y thing, and you're not talking about an x thing. All right, so that's it.